All right, in chapter 6, we'll talk about zone-based policy firewalls. In this chapter, we're going to look at the two configuration models for Cisco IOS firewalls. We'll look at the advantage of the zone-based policies, the zone-based policy firewalls over the classic firewall model. We'll look at the step-by-step process of configuring a ZPF. And we'll also look at how they can enhance security while simplifying the management of your firewalls. All right, so Cisco IOS, they offer two firewall configuration models. You have your classic firewalls, which the policies are applied directly to interfaces. They use the access control lists and inspection rules to filter the traffic. Now, these classic firewalls, they can be complex and hard to scale in large networks. You also have a zone-based policy firewall. Now, with this one, instead of applying the interfaces policies to the interface, the zone-based policies are grouped into security zones. So with this, the firewall rules are applied to traffic moving between the zones rather than the individual interfaces. Now, the main reason to migrate to the ZPFs are its structural approach and simplified management. So with the structure, instead of managing firewall policies per interface, the zone-based organized security policies by the zones. This makes it easier to document, communicate, and troubleshoot any security rules. You also have easy use with this, so it eliminates the need for extensive ACLs on multiple interfaces. So the firewall policies are applied at the zone level, which simplifies security implementation. So these benefits make the zone-based policy firewall the preferred firewall model for modern network environments. Now, a major advantage of the ZPFs is that it simplifies the network expansion. So if a new interface is added to an existing security zone, its host can communicate with all other hosts in that zone without any additional configuration. This reduces the need for manual ACL adjustments when scaling your network. So we'll see the diagram on the slide. This illustrates a simple three-zone network where the traffic flows based on zone-based policies rather than interface-based. Now, there are several key advantages that the ZPS offers over the classic firewall model. Like we said, it's not dependent on the ACLs. So it uses the Cisco Common Classification Policy language to define the traffic rules. The default deny all security posture is enabled. So unlike classic firewalls, which permit by default, ZPFs block traffic unless it is explicitly allowed. Also, scalability. So one policy can control multiple traffic types, which reduces the complexity. It also supports physical and virtual interfaces, and they can be grouped into zones, regardless of the type. Now, ZPFs and classic firewalls, they can coexist on the same router, just not on the same interface. So we look at ZPF designs. There are several steps involved with this. The first step in designing a ZPF's implementation is to define the security zones. So the zone represents a security boundary where the traffic control is applied. Some commonly used security zones include the private zone, which is a trusted internal network, your public zone, which will be an untrusted network, for example, the internet, and then also a DMZ zone, which is publicly accessible services such as web and mail servers. Now, when you group these interfaces and zones, we can apply consistent security policies across multiple interfaces. So we have these zones defined. After this, we must establish the policies for traffic movement between them. So our firewall policy should define what types of traffics are allowed between the zones. This will include our TCP, UDP, and IMCP sessions. For example, like we allow the HTTP traffic from a private zone to a public zone, but we may block all traffic from public zone to the private zone except for the return traffic. Now, by controlling the traffic flow between the zones, the ZPF, this ensures secure communication while preventing unauthorized access. So, as we define our zones and our interzone policies, the next step is to design the physical infrastructure. So, you want to take into consideration the network topology and device placement when designing your physical infrastructure. Some other factors to consider is security. You want to ensure that proper isolation of sensitive networks. You want the availability uh, of your network. So you want to implement redundancy. You want to avoid that single point of failure. And also, you got to consider the performance. You want to avoid congestion in heavily used zones. Now, step 4 is to identify zones with identify subsets within zones and merge traffic requirements. So, if you have a complex network, multiple subzones may exist within a larger zone. So, the administrator must identify the zone subnets and merge the traffic policies whenever necessary. An example of this may be a private zone that has two subzones, for example, user workstations and internal servers. So, those policies should allow specific traffic between those subzones while blocking unnecessary communication. So, this helps organizations um, optimize their security policies and also helps to ensure that you have efficient traffic flow within your zones. Now, once the zones and policies are established, the ZPF enforces specific actions on traffic. For example, there's 3 possible actions that can be configured for that traffic. You have inspect. So this performs a Cisco IOS stateful packet inspection, allowing return traffic only for established sessions. So, example of this: if a private host initiates a TCP session, the return packets are automatically allowed. Now, the drop, this explicitly blocks traffic. This is similar to a ACL deny rule. So, for example, for this, it may drop all inbound traffic from an untrusted network. Now, it does have a log option that's available to log rejected packets. The pass allows traffic without tracking the session state. Um, this uses specific protocols with predictable traffic patterns, such as IPsec VPNs. Now, each one of these actions determines how the firewall handles the traffic between those security zones. Now, the ZPS also controls how packets are forwarded between interfaces based on their zone membership. So, if both interfaces are in the same zone, the traffic's allowed. If neither interface is in a zone, the traffic is allowed. If one interface is in a zone, but the other one is not, the traffic is dropped. And if both interfaces are in different zones and a policy exists, the policy is going to dictate if the traffic is inspected, allowed, or dropped. Now, the self zones, these refer to the router itself. This includes all IP addresses assigned to the interfaces. This rule applies to traffic that originates from or is designated from the router, destined to the route from the router. Some examples of this include device management, like SSH, Telnet, or any routing protocol communications, um, or also self zone. So, some self zone rules. For example, if the router is the source and the destination, that traffic is permitted. If a zone pair policy exists, the defined policy is going to be applied. Now, if you don't have a specific policy, traffic is going to be denied by default. This ensures a controlled access to the router, but it also allows essential management traffic as well. So when we configure a zone-based policy firewall, there are 5 steps that we have to go through. We create the zones. So we define the security zones to group the interfaces together. We want to identify traffic with a class map. This specifies what types of traffic the firewall will inspect or filter out. You want to define an action with a policy map. So this is where you assign the inspect, drop, or pass actions to that classified traffic. You identify a zone pair and match it to a policy map. This defines the traffic flow between the zones. And finally, you assign the zones to the appropriate interfaces. So we want to apply that firewall policy to the router interfaces. So we'll look at these a little bit more depth. So the first step in configuring a ZPF is to create the security zones. Now, before you create these zones, you need to ask yourself some questions. Which interfaces belong to which zones? What will each zone be named? And also, which types of traffic should be allowed between the zones? So after you define these zones, from here we're going to start applying the policies to control the inter-zone communications. Now, the second step is to identify and classify the network traffic. So class maps are used. They allow administrators to define specific types of traffic that the firewall will act upon. And also a match condition, this determines what packets are included in that class. So the packets must meet one of the match criteria, either match any or match all. As you see on the screen, the commands for defining the class. So when you create that class map, administrator can specify how traffic should be matched using 3 primary parameters: match any, match all, or class map name. So each of these parameters define how traffic is classified in group. So the match any parameter, that means that the packet only needs to match one of the defined criteria to be considered a member of that class. So this is the equivalent to a logical OR statement. Example of this would be like if we had it set up to class match, match any web-services. So that would match the protocols for HTTP, HTTPS, or DNS. Now, you would use the match any when you need to group multiple related traffic types without requiring all conditions to be met. For example, I just gave allowing the multiple protocols like the web browsing and DNS under the same policy. Now, the match all parameter means that the packet must meet all of the defined criteria to be classified in that class. This is like the logical and condition in programming. So you would use this when you need to apply multiple strict conditions before the traffic is classified. For example, if you want to only allow an encrypted HTTPS traffic from specific IP addresses, this is when you'd use the match all. Now, the class map name, so instead of defining new match conditions, you can use existing class maps as the criteria for the match. So what this does, this allows for nested classification, making complex policies easier to manage. So you would use this when you need to reuse an existing class map instead of duplicating match conditions. For example, if you want to group multiple predefined traffic categories into a larger classification. Now, there are three primary match parameters that can be used in a class map. You have your match access group, match protocol, and match class map. So the match access group, this parameter matches traffic based on an access control list. Um, with that, the ACL's number or name is used to define which traffic belongs to which class map, to the class map. This is something you would use when a specific IP address or networks are needed to be controlled, or when applying fine-grained filtering based on custom ACL rules. Now, the match protocol, this matches traffic based off a specific protocol. It's used to group and apply policies based on traffic types such as HTTPs, DNSs, HTTPSs. This is something you're going to use when controlling access to web servers, voice over IP, email, and other application specific traffic. And you also want to use this when you're ensuring only certain protocols are permitted between the zones. Now, the match class map, this uses an existing class map to match the traffic. This allows, once again, nested classification, meaning that the class map can be referenced. They can reference another class map. This is something when you use when you're managing multiple class maps, and also when needing hierarchical traffic classifications for better policy management. We'll see on slide 15. We're going to define a class map. We look in here, we'll see that here we got the match. With match protocol, HTTP, HTTPS, DNS. So this class map groups these together into a single class. The reason why this is done this way is because it's commonly, these protocols are something that's commonly allowed between private and public zones. To give you a sample of using a class map. Now, the next step is we're going to define an action with a policy map. So after we classify our traffic, we go into the next step to define firewall actions using the policy map. Now, once again, the policy map assigns those actions of either inspect, drop, or pass to identify the traffic. Those actions are based on class maps that are defined in the previous step that we went through. So we see on the example here, we have our policy map type, class type, inspect, and the code that shows the command syntax for configuring a policy map. Now, these actions that we talked about, the inspect, drop, and pass. Inspect enables stateful inspections of the connections. Drop blocks traffic explicitly, so it drops that unwanted traffic. And pass allows those traffic without tracking the session state. So we're going to look at the example here. We're going to break down the command, what this does. So we see the policy map, private to public policy. That's being defined. This creates a policy map that's named private to public policy. So the text that's in orange will be the name for the policy. Now, this policy is going to define how traffic is treated between those zones. We next look at the class HTTP-traffic. This associates this policy map with the HTTP traffic class map, something that was defined earlier. This ensures that only HTTP, HTTPS, and DNS traffic are affected by the policy. Finally, the inspect. This configures the router to inspect the HTTP traffic class. So that means the router will perform stateful inspections, which track session states for TCP and UDP traffic. It returns traffic to the public zone. Return traffic to the public zone will be automatically allowed if it's part of that established session. Now, in a zone-based policy firewall, the firewall enforces security rules by taking specific actions on traffic passing between the security zones. So this action determines whether the traffic is allowed, blocked, or inspected as it moves through the network. There are three primary actions in a ZPF. So the inspect, we've talked about, it enables a state-based traffic control in ZPF. So when traffic from a private zone to the public zone is inspected, the router tracks that session state. It allows return traffic from the public zone only if it belongs to an established session. This behavior is going to be known as stateful inspection and ensures that the responses to legitimate requests are permitted automatically. Now, the reason why this is important is because it does prevent unauthorized inbound traffic, but once again, it allows the legitimate return traffic. It also enhances security by ensuring only valid sessions are maintained. And this is something that's recommended for most application traffic, including your web browsing, emails, and voice over IP. Now, the drop is the implicit deny policy. This drop action blocks traffic by default. As we talked about, it's similar to the ACL deny rule. Now, every ZPF policy map has an implicit drop rule at the end of it. This means that any traffic not explicitly permitted is automatically denied. So if the traffic matches the drop rule, it's silently discarded without sending an ICMP unreachable message. This prevents attackers from probing the network to identify the firewall rules. Now, why would this be important? Once again, it blocks unauthorized traffic without alerting potential attackers. And that's also the default security posture. So by denying all unless it's explicitly allowed. Now, administrators should carefully define those policy maps because you want to ensure that legitimate traffic is not unintentionally dropped. The pass action allows traffic to be forwarded between zones without tracking the session state. So router does not monitor where the connection is established. The pass action is one way, meaning that the return traffic requires a separate policy. Now, you would use a pass when you need to set up a secure, predictable protocols such as IPsec, VPN tunnels, and so forth. This is not something that's going to be recommended for most application traffic because it is something that lacks that stateful protection. Now, for most network security scenarios, inspect is preferred over pass because it ensures return traffic is automatically permitted. Step 4, we're going to identify a zone pair and match it to a policy map. So a zone pair specifies the source and destination zones for the traffic flow. A policy map is then assigned to the zone pair to control the traffic movement. So we'll see an example below of a zone pair, of defining a zone pair. So in this example, you see the private pub is a zone pair name. Private is the zone source. Public is the destination zone. So the private to public policy that we created a few slides back, this is something that's going to be assigned to this zone pair. Now, it's important because without a zone pair, the firewall policies cannot be enforced between the zones. Once again, remember, policies only apply to traffic moving between explicitly defined zones. So now we've fully defined how traffic should flow between these zones. Now, the final step in configuring a ZPF is to assign interfaces to the appropriate security zones. So, this is a step that binds the firewall policies to the actual network interfaces. So, up until this point, until that interface is assigned to a zone, all transit traffic through it will be dropped. So, we see an example here of assigning interfaces to zones in your command line interface. So, you see you have your interface and then the gigabit Ethernet 00 being assigned zone member security private, while the serial 000 is being assigned the zone member security public. Now, once again, the reason why this is important because without these zone assignments, the firewall rules will not take effect. Now that we've assigned our interfaces, the traffic is evaluated against that zone pair policy. So now we've got a fully configured ZPF. We're ready to enforce our security policies. Now, when we configure this, the next step is going to be to verify the configuration to ensure the policies are applied correctly. Now, some key commands for verification. You want to view the running configuration. So you'd use the show run config or show run, run dash con. This displays the configured security zones, zone pairs, and policy maps. In here, you want to check the security zones and assign interfaces. You would use the show zone security command. To view active policy maps and their rules, you would use the show policy-map type inspect. This shows what traffic types are being inspected, passed, or dropped. And you can use these to validate that the ZPF is functioning as intended. Now, after you've went through and verified, you should test real traffic to confirm the firewall rules are being enforced correctly. So, for example, testing traffic flow between the zones. In this situation, we're going to test the HTTP connection from a private zone host to a public web server. So we're going to use Telnet in this. And type in the IP address of 10.1.1.2. So if the policy allows the HTTPS connection, if it allows it, that connection should be established. From here, you would use ICMP, which is ping, to test the drop traffic. If that ICMP is not explicitly allowed, the ping should fail. Now, test is important because it helps verify if the firewall policies are correctly applied. It also ensures that legitimate traffic is allowed while unauthorized traffic is blocked. Now, if you have any unexpected behavior during this, you want to use debugging commands to investigate that. Administrators can also use additional ZPF verification commands to troubleshoot issues. Some other ones, you can view the real-time traffic logs by using debug IP packet detail. Some other commands you can use is show zone-pair security to check active security pair policies. Show log will monitor firewall activity with logging enabled. Now, you do this because you want to make sure that the policy is not working as expected, that these commands are going to help you in diagnosing those issues, and also help to ensure that the ZPF is properly enforcing the security rules. Now, in this one, you'll see that an example of HTTPS session from a private zone. So the show policy map, type inspect, zone pair, private pub command that was used. In here, they're showing the packet status, how many packets were inspected, allowed, and dropped. Now, when you configure a ZPS, there are important considerations to keep in mind. Once again, the traffic between interfaces is in the same zone or always allowed. The ZPF only inspects inter-zone traffic, not intra-zone. Interfaces cannot be assigned to multiple zones. They cannot belong to multiple zones, so each interface can only be assigned to one security zone. The ZPF cannot coexist with classic firewalls on the same interface. So you'd use the remove IP inspect commands before applying the ZPF policies. Your traffic cannot flow between zoned and non-zoned interfaces. So when an interface is not assigned to the zone, it will drop all transit traffic. Also, applying zone member configuration interrupts services. The interfaces may experience a temporary outage when assigned to a zone. Also, keep remember that these are important because it helps prevent misconfigurations, something that could disrupt network security policies, and also ensures that the firewall rules are applied efficiently.